Okay, so for chapter 16C, the three new concepts you need to learn are variance, standard deviation, and the interquartile range. All right. Okay. Remember I mentioned standard deviation before? Yeah? What is standard deviation? What do you guys remember so far?
Variance in...
Yeah. Variance in, yeah?
Data.
It's a variance in data, correct? So have a look at this one here, right? Look at the graph here. Red and blue, which one has more variance?
Blue.
Blue, correct, right? Make sense, Emily? The blue graph has more variance because it's a wider, right? It's spread out more widely, okay? So think of it this way. If I were to take two values, let's say these two values here and here, right? Which graph has a bigger area in these two values? Let's say that's 0 and 1. Which graph has a bigger area between 0 and 1?
The blue.
Not quite. Bigger area between 0 and 1, yeah? So which one has PR of 0 less than x less than 1? Which one has a bigger value? Red. Why?
It's higher.
Hey? Well, yes, it's higher, right? Because we're talking about area under the curve. So for the red curve, this is the total area, right? Make sense? Yeah, because probability is the area under the curve for the PDF, right? And then the blue curve only has only has this much. Okay, so the red probability, right? The probability for the red has the bigger area than the blue. What does that mean? So there's more, right? There is more red items. That the chance of you if you get a red item, the chance of it falling between 0 and 1 is in this value is more than blue. So it's less spread out. Does it make sense? If you have 1,000 items, right? There's this much red item more than blue that will fall within the area 0 to 1. Right? So within the same area, a smaller spread would have more values in there, and that makes sense, right? A really low spread could look something like this. Could look something like that, right? That one, the green one, has extremely low variance, okay, compared to the blue and the red ones. Make sense? Yeah. So that's just the definition of variance. Now, how do you actually calculate variance? Well, you just got to memorize the formula. Okay, so it's just something you need to memorize to use that value here. Okay, variance is x squared minus mean squared. I'll explain that later. Just remember, use the formula, and the standard deviation is the square root of variance. Okay, why is standard deviation useful? Well, later on you understand in a few chapters, like why you need to learn about standard deviation. Okay, that standard deviation is like it's called standard for a region. Deviation is how much it deviates from the mean, and standard is the probabilities are quite standardized. You'll see that in the next chapter. I won't explain too much about it. Just remember, standard deviation is square root of the variance. That's it.
How much different is it to the one we do in general maths? Because we've done standard deviation in that. So
the concept is the same. It's the same standard deviation, but in math methods you will be calculating standard deviation more accurately. Yeah. Okay. I think in general math you use the data, but in math methods you use functions.
Yeah,
I think.
Use data,
yeah, you guys use data for general math. But yeah, anyway, so skip all that. Now, example 10. Find the variance and standard deviation of the following PDF. Okay, so this is now chapter, you draw a quick line here, and this is now chapter 16C, measures of spread. So the first one is variance and standard deviation. Okay, you guys remember the formula for variance? I flashed it to you once. Do you remember it? var of x equals to? Oh yeah, okay.
X squared.
Yes, e of x squared minus
mean squared.
Minus the mean squared. Okay, good. Okay. First time seeing the was it your first time seeing the formula? Perfect. You know, very good memory, right? So yes, e of x squared. So minus mean squared. How do we do this thing though? Okay, mean, we know how to do mean, but what is this e of x squared thing? Alright, I'll show you guys how to calculate it. Remember, so mean, right? So I'll do them side by side here. So this one, once you know how to do it, you do that first. But let's just say you want to calculate the mean first. Okay, what's mean? Mean is e of x, right? See the difference between this one? This is x squared, that's 1x. So how do you calculate it then? Let's wait and see. So remember, e of x, the mean is antiderive, left to right of what? Not just the function, we need to antiderive of not just the function, not just 0.5x, you need to, it's not just 0.5x dx, it's missing something.
X.
Yes, you times x into the function and then you antiderive. Okay, it's x times 0.5x. Alright, so if you were to work this one out, that would be antiderive of 0 to 2 of 0.5 x squared. Alright, and then you can take the 0.5 out, antiderive just the x squared. So that's 0.5 x cubed over 3 from 0 to 2. Okay, make sense? Yeah, the rest is just algebra. Okay, so follow my algebra, but it should not be too difficult. 0.5 is 1 over 2 sub 2 minus sub 0, which just means you sub 2, and that would be 8 over 3. Okay, because when you sub 0, you just get 0. Yeah, so then 2 and 8 cancel out, so the answer here would just be 4 over 3. Any question? No? Yeah, so this is what, just a recap, this is mean, right? The mean is 4 over 3. Right, that's the average of the function. Now, what do you think is the way to calculate e of x squared? The hint is, this is e of x, it links to x times in. What do you think about e of x squared? How do you find e of x squared? What do you guys think?
Add an x in.
Sorry?
Add an x in or square the whole thing?
Not square the whole thing? What do you mean by add an x in? If you were to make a guess around that, what would that be?
Make it x squared.
Yes, make it x squared. Very good, good intuition. Whatever this thing is, the big X is essentially what kind of small x you are multiplying in the function. Does that make sense, Emily? E of x squared just means you times x squared into the function. Yeah? So another example, what is e of, say, x to the power 3 or x to the power or square root x? This would be antiderive, left to right of
Square root x times the function.
yes, just square root x times the function, but note that this will be capital X. It's just square root x times the function. Okay, so in fact, generally, if this is f of big F of x, f of big X, then this would just be that same function times into, let's just call that g actually. Then that would be the same function time of small x times into the other fx and antiderive it. Okay, so this one would just be x squared times into it. So bring out the 0.5, again, that's 1 over 2, and then antiderive x cubed would be x power 4 over 4. Yep, from 0 to 2. Okay, again, sub 2 minus sub 0, sub 2, sub 0 is 0, so sub 2 would be 16 over 4. Okay, so that would just be 4, and 4 times 1 over 2 is 2. Okay, so e of x squared is 2. All right. Now, actually, I'll write it this way. So equals to 2, and this is e of x squared. So what is the variance again? Variance is e of x squared minus mean squared. So once you've got these two, so remember, there's just two things you need to do. Okay, the first one is to find e of x squared, and then you find mean, which is e of x. Right, and after you found those values, just chuck them into the formula. Var x equals to e of x squared minus mean squared. Always rewrite the formula at this stage, so you always memorize it. If you have to write this enough so that when you see it in the exam, you know exactly what to do, like in a second. You can't think about, how do we calculate variance? GG. Okay? In Unit 4 exam, it's harder than Unit 3 exam. Alright? So these things you need to be able to get it straight away. So that would be 2 minus 4 over 3, everything squared. Okay, because we found mean, but not the square of mean. All right, so you got to square that. That will be 2 minus 16 over 9. Once again, 2 is just make it same base. That's 2 over 1. So that's 18 over 9 minus 16 over 9. And so that would be 2 over 9. So that is the variance of x. Okay. Now what is the standard deviation then? Sigma is the standard deviation. Alright. Let's see. Yep, okay. So they ask you for standard deviation. So sigma would be square root of the variance, which is that, and then that would be square root 2 over 3. That's the standard deviation. Does it make sense? Yeah? Okay? Yeah? Alright. Can you guys quickly find for me, so we know the mean is 4 over 3, right? Okay, so the mean is 4 over 3, yeah? And then the standard deviation is square root 2 over 3. Can you quickly find what's the probability that the x value is, because if you were to graph this, right, let's say if you have the mean is like here, okay? If you plus 1 standard deviation, so mean plus sigma, and then you subtract 1 standard deviation, mean minus sigma, okay? What do you think is the area between these two values? Okay, so these two values, I want you guys to find the area between these two. So remember, mean is 4 over 3, right? So this one here is 4 over 3, and this is 4 over 3 minus sigma, which is root 2 over 3. And this one is 4 over 3 plus square root 2 over 3. So you want to find the area between these two values. Punch that into your calculator.
Wouldn't it be 2 sigma?
Sorry?
Wouldn't it be 2 sigma?
No. So we're finding the area. So remember, you're anti-deriving. Yeah? It's not just take this minus that. No, it's you're anti-deriving between these two values. And then remember the function fx. Okay, fx is basically 0.5 times x. Okay, so this area would be anti-derived from the left, which is 4 over 3 minus, oh well, let's just combine them. So that's 4 minus root 2 over 3, and the right hand side, which is 4 plus root 2 over 3 of the function fx, which is 0.5x dx. All right, punch that in your calculator. Tell me what it is. Okay, my guess is it would be roughly about 68 or 0.68. Okay, if I were to make a guess, it would be 0.68. See what the actual value is.
Is it 0.628?
What was it?
0.629.
So 0.629. Right? Okay. Yeah. Alright. So yes, have a look guys. My guess was 0.68 and the actual answer was 0.629. Hang on, let me I'll wait for Emily first to see if she actually gets the same answer. What did you get?
4.8.
Okay, 4.8 is way too high. Try again.
Oh, there you go.
629, yep. 0.629 is the right answer. Okay, all right. So so this is roughly about 63%. Okay, my guess earlier is 0.68, which is about 68%. So it's not too far off. Okay, the two answers are quite similar, and this is the meaning of standard deviation. Okay, standard deviation is it tells you the variance in the value that normally when you plus minus one of the value 68% or 60 something percent, normally 68%, as you will learn later, will fall between the two values. Okay, it may not make any sense. I'll give you an actual scenario. Give me a, let's say Pringles. Okay? Do you guys know what Pringles is? Do you guys eat Pringles? Do you guys like Pringles? Yeah, to a certain extent. So you understand the idea of a can of Pringles and it has a weight, right? So let's say if you buy a can of Pringles, it's 100 grams. Do you think that when you weigh all the chips in there, is it exactly 100 grams? No, right? Because remember, the probability that X is exactly equal to 100 grams is equals to 0. There's no way you're gonna get 100.0000. So you get like 99 point something, 98 point something, 102 point something. Okay, but how do we control the value then? So for example, right, is this good? Let's say if you get 5 cans of Pringle, right? 1, 2, 3, 4, 5. You get 5 cans of Pringle. The first one, when you weigh to, let's say the two 1 decimal place, is 99.1, and then the next one is 98.9, and then it's 100.1, 101.9, and 102.6, for example. Let's say you got 5 cans of Pringles. They weigh these values, okay? And then you have the let's say if you have so this is the Pringle cans. And then let's say if you buy a dodgy, don't know X brand that is like trying to compete with Pringles. And then the values that you get are, let's say 97.5, 98.9, 105.1, right? 96.2, 99.1. Okay? So if you look at the values closely, they are kind of the same, aren't they? They're kind of similar, right? They're around 100. Does that make sense? They're around 100, but how do you know which is better? And how do you know which one has a higher spread? So we don't know, we can't actually compare, right? But let's just say if we say that the Pringles has the mean, let's say they both have the mean of 100, okay? So the mean, if you take like about 100 point something, let's say 100.0 for to 1 decimal place. And the Pringle cans is also, the mean is also 100.0. So let's say you take 100 cans of Pringles and brand X, and then you take the average is about 100. Okay, let's say the mean is exactly 100, but Pringles, the standard deviation or sigma, all right, so this is the standard deviation. So for Pringles is 0. Let's say is 1.1, and then for that brand X, the sigma value is 2.1. Which brand do you think is better, and why?
1.1.
1.1 is better. Why? Because
It's a lower value.
it's a lower value, means has a lower spread of values. Okay. In fact, you can say later on you will learn that 68%. I said that number earlier. 68% of the Pringle cans, if this is the value, right, will have the weight between 100. Let's just say this is 1 and 2. Make it simple, right? So 68% will have the weight between 99 and 101. Okay, so 68% of the Pringle cans would have the weight between those two. But for brand X, 68% will have the weight between 98 and 102. So it's a higher spread. If you were to put this on a number line, that would be like, let's say 98, 99, 100, 101, 102, 99, 100, 101, 102. The Pringle cans will look more something like this, right, in terms of the distribution. And then the other one, the blue one, would look more like this in terms of distribution. Does that make sense? So the area for the red line between 99 and 100, this area is, I'm looking at this one, yeah? This area is 68% or 0.68. And that is the same. And to get the same area for the blue, you need to look at this entire region here. Right? That region is also 0.68. So it's spread over a wider range of values. Okay? So this is the meaning of standard deviation. It tells you which product or which quantity has a higher spread of values. Make sense? Yeah, so that's the intuition for standard deviation. And just me in saying this, but if you understand it, when it comes to the school to teach standard deviation, see if you can help your friends out. Right? And they may understand like, oh yeah, that's how you calculate it, but they may not have the intuition of what that means. Alright, so help the friends out when the time comes. It will also help you revise these concepts. Remember, the best way to learn is to teach someone else the concept. Alright. Okay, so that is standard deviation and variance. Next, actually, I'll get you guys to do some exercises first. Okay, let's try. Okay, let's try an actual question. Okay, okay, all right. Yeah, simple one. Question 1. Okay, so for this question, I will start the question first, get to the point of, and then I'll pause and let you guys work it out first before I show you guys start working on the full answer. So this one, the variance of x and hence the standard deviation. So variance, the first thing you find is e of x squared, and then you find the mean, which is e of x. So the stuff in red you have to write. Okay, there's no way you can go without not writing these. So that's antiderive from left to right of x squared times 2x dx, and then mean is antiderive from left to right of x times 2x with respect to x. Okay, I've laid it out for you guys to start already, and then the formula is var x equals to e of x squared minus the mean squared. Alright, work on this question. Suleiman, if you're listening to this, start work on this question as well. And I'll slowly work through the answer. Make sure you write the var x formula before you continue putting in the values. Okay? I don't want to see a value straight away. You have to write the formula for like 100 more times. So standard deviation, instead of writing the symbol sigma, which is like a circle with a line on the top to the right, you can also write SD or standard deviation, SD of x. Alright, that's another way of writing that. Okay, so note that so note that for fractions, right, you want to rationalize the denominator. So the denominator is always a whole number. Right? So have a look at how I rationalize that. Any question? Alright, if you guys got these answers, then try question.
How do you get it from 1/3 √2 to √2/6?
Okay, good question. I was waiting for that question. Surely you guys have a question around that. I wrote a short form for a reason. I want to see if you guys actually try to understand this. Good question. How do I get from here to here? The answer is, and here's the explanation. I'll move that one to the side. I skipped a step intentionally. See if you guys would actually get it. But I times top and bottom by square root of 2. Okay, so if you times top and bottom by square root of 2, then you've got that one times square root 2. When you do √2 times √2, that's just 2, right? Okay, so that would just be 3 times 2, which is 6, and then the top is just square root of 2. Okay, so it's times by the same square root. Technically, there is another way of doing that. Here, you can times top and bottom by square root 18. So the top would be root 18, and the bottom would cancel out to be 18. That make sense? Yeah, times root 18 over 18, and now you can rationalize the top. You simplify the top, so that's root 9 times root 2 over 18, which is 3 √2 over 18. Simplify 3 and 18, that will be √2 over 6. Either way, you get the same answer. Okay, so I just had to simplify it first, so I don't have to multiply by a big number, but you can do that too. It doesn't really matter. The steps are almost the same. Alright, so same way, same answer, √2 over 6. So if you've done that, start on question 5. This time, I'm not giving guys any start at all. Let's see if we can get started with it first. Find the value of k, and then find the mean and variance of x. You give your answer to 3 decimal places. That means this is a calculator question. But note that the value of k is an exact number. Okay, so the value of k must be an exact number. This one. And then question B is a calculator. Alright, so try question 5. If you get an exact number for k and then use a calculator for B, because you need 3 decimal places. How do you antiderive 1 over x? Yes, very good.
Can you use calculator to go further?
No. Yes, you can, but if you get 1 over ln9, it should be okay. Because you need the value of k to do the next part right? So that's why normally you want to get an exact value of k if you can. And now then you can use your calculator for question B. Find the mean and variance of x.
You just answer perfect balance.
Yeah. Just use your calculator. Once you've got the formula, you can just use the calculator. But note that so how you need to get to the formula first, right? Write what I'm writing and keep on getting to the formula first, and then you write using GC. The answer is whatever. Alright, so don't get straight to the answer. You gotta show some working. I have a feeling you guys will have a question on this. When k is 1 over ln 9, how did I get to that other point? It's k over x, right? How did I get to the other point? Well, x times, bring this to the side as a separate factor, right? So that'll just be 1 over ln 9 times by 1 over x. Alright? Okay, so remember, it's like either you can multiply this with the 1, or you can take it out as a normal fraction multiplication, right? Which is what I did there. And so that means that the 2x even will cancel out each other. What will be 1 over 9 times, sorry, integral from 1 to 9 of 1 over ln 9 dx. Any question? No, keep going. You gotta write that in all the way up to that point, and then using GC, you get the answer here.
Wait, but what x would you sub in the values into?
Sorry?
What x value would you sub the values into?
You don't sub the value in...
Like for when you enter derive, and then you sub 9 and 1 into the...
When you enter derive 1 over ln x, what do you get? It's a constant, right? So what do you get?
0. Wait.
Not 0, that's derived. When you enter derive a constant, what do you get? So
X.
when you... Yeah, so enter derive 4 it gives you 4x, yes, just, because this is x power 0, right? So you raise the power to x power 1, and then you divide by a new power.
Yeah,
okay? Yeah, so that's how you do constant. But you don't even bother with that. Once you get to this one, just punch that whole thing into a calculator. Okay, this is a calculator question. Just get to that, and then using GC, get the answer. So your answer should look something like 3.640957. The reason why I'm writing more decimal places is, Emily, why am I writing more decimal places here? Why do you think I'm using more decimal places? Even though they asked for 3 decimal places. Why do I need more here? And yes, I do write the final answer as 3.641. I highlight this, but why do I write more decimal places first? What's the formula for variance? Variance is?
Something x squared.
Is the e of x squared, right? And then minus mean squared. Okay, because I'm using this mean value again in the variance calculation, I have to use more decimal places. Otherwise, you won't get the right decimal digits in the final answer. Okay, so this is considered an intermediate value. Intermediate value. Okay, so you need to use that to calculate something else later. And so if you need to use something to calculate something else, you need to put that value into more decimal places, as many as you're comfortable. At least 2 or 3 more. Right? Because otherwise, if you just use that value, you won't get the right variance later.
Can you how to get from the first to the second?
Which one?
Of B.
For B, from here to here? Yeah, so this is essentially bring that one out as a separate multiplication. It's like if you see 3 over x, right? This is the same as 3 times 1 over x. Does that make sense?
Oh.
Right? So instead of 1 over ln 9, I'll just bring it out as a separate thing that is times into 1 over x. Okay? That can look a little bit strange, but that's just how it's worked through. Yeah, and the questions are, have you got the variance?
No.
Then calculate the variance. You're not done yet. You can flip back to the notes to find the formula for variance, but you gotta calculate the variance just using the calculator. But remember, to do the variance, you need e of x squared first. So you should calculate that one first. Your rounded decimal place needs to be exactly as the answer. Okay, if you're off by 1 digit, you're going to get the full marks. If they ask specifically to 3 decimal places. All right, let's move on. So now we're going to, okay, do you guys remember interquartile range? What is the interquartile range? Interquartile range, or IQR. Remember this one from like year 9? Yeah? Sahab, what's the interquartile range? No. Remember hearing it, but not the formula of it. This is the same as the upper quartile minus the lower quartile. Make sense? You sure? What's the upper quartile?
Upper quarter.
Sorry?
A quarter or upper half or...
Yeah. A quarter of upper half, yes. Okay, lower quartile. Okay, so if you have the... Okay, so let's just say we have the upper quartile as the value A minus lower quartile, which is the value B. Okay, so what does that mean? It means that, so remember we've got, let's say that this is a PDF, right, between certain values from here to here. Let's say that's some sort of PDF function. Okay, we learned the median is the value that chops the area in half, right? Half and on the left, half on the right. The lower quartile let's see, A or B, oh no, they use this one as B minus A. Okay, so you find the lower quartile first and the upper quartile. Okay, so the lower quartile is half of the lower half, which is what Sahal said earlier. Half of the lower half. What does that mean? It means that this area is, Emily, what's this area?
Something I don't call.
This area is how much?
Oh.
This area is how much? From the left all the way to the median is how much?
0.5.
Yes, which means this is,
0.25.
yes, this is 0.25, okay? Yeah, and then this will also be 0.25. So right now, this big one is 0.5, but if I chop that in half again, all right, I chop that in half again, the value B, and that means this is 0.25, 0.25. This is the lower quartile. Alright, it's a value that 25% of the population will be lower than that, and then B is the upper quartile where 75% of the population is lower than that. Does it make sense? Yeah, make sense? Okay, now that you guys have hopefully understood the main concepts, let's look at this one here, interquartile range. Okay, so first we'll calculate the lower quartile. Okay, so how do we calculate lower quartile? Lower quartile. What do you guys think? Area to the left of that is 0.25. So, any idea?
Make it equal 0.2, the area to equal 0.25.
Yes, area equals 0.25. Alright? Area equals 0.25. Okay, yes, that's the right idea, but how area from where to where?
From 0 to 1.
From 0 to 1 is wrong. If you anti-derive from 0 to 1, the answer will be 1.
0.25. 0 to 0.25.
No, 0.25 is the area. You want the value. And that value is the lower quartile. It's like the median. Okay? So remember, these ones are the values on the number line. And this one is the probability. Okay? Don't be mistaken. Okay? So this is the x-axis values. Right? And then this is the area. Okay? So we want the lower quartile is an x-axis value. Right? X-axis value. It's a value on the x-axis. That's why I call it x-axis value. Make sense? Yeah? It's a value here. Remember? It's on the x-axis, right? And then upper quartile is also on the x-axis. Same with median. It's a value on the axis. And then the hovering thing is the area. So the area is 0.25, but then how to get 0.25? It's essentially anti-deriving from the left to the lower quartile. Does that make sense? Does that make sense? Yeah? Visually, it looks something like this. Say that's a PDF, right? PDF, right? When you anti-derive from 0, this is 2x, so let's just say that it's just a straight off line from 0 to 1. Okay, this is the shape of the graph. What they're saying is, what's the value A, the lower quartile, where the area to the left of A is 0.25. So you anti-derive from 0 to A, and the answer should be 0.25. Does it make sense, Emily? Yeah? So that explains that little bit here. So anti-derive of the equation, the answer should be 0.25. And then you just got to work out what A is. Right? The rest is algebra. So that would be x squared over 2, which is just x squared, and then 0 to a equals to 1 over 4. Sub a minus sub 0, a squared equals 1 over 4. And now a would be equals to 1 over 2, or a equals to negative 1 over 2. Which one is rejected and why?
I think negative.
Emily? Negative is rejected, why?
Because it can't be a negative number because it's
Yes, because
above 0.
it's above 0, correct? Rejected because what's the domain? The domain is from 0 to 1 only. You can't get any value that's less than 0 or more than 1, right? A can't be here either. It doesn't make sense. There's no way A can be like at a point where the area to the left is already 1. Okay, so yeah, so you see when you're solving, you have to pick the right value. So yes, A is equals to 1 over 2. So this is the lower quartile, right? Lower quartile. Make sense? Yeah? So what do you think is the upper quartile? Let's say upper quartile is B, right? Okay, so looking at this, how do we find the upper quartile?
Wouldn't the upper just be 1 minus A?
No, not 1 minus A. That's the range of values from A onward. But upper quartile again is the number on the number line. B, where the area to the left of that is what? Is how much? Or the area to the right of it from B all the way to 1 is how much?
0.25.
Yes, this is also 0.25. So the area to the left of B is, so how?
0.5.
No, 0.75. I mean to the left as in like all the way to the left.
Oh, yes.
Then yes, it's 0.75, right? But you can either use 0.75, but in this case, I'll show you guys an alternative version. So n to the right from B to the right hand side should be 0.25, right? Okay, so to the right of B would be 0.25 as well. And that would be the same thing here. All right, so that'll be x squared calculated from 1b equals to 0.25. And then 1 minus b squared equals to 1 over 4. Okay, bring b squared over, subtract that, then I get 3 over 4 equals to b squared. And once again, you got b would be square root 3 on 2, or b would be negative square root 3 on 2. This is rejected. Rejected, right? Because b has to be between 0 and 1. Okay, it's between these two values here. Right, which means we've got b equals to square root 3 over 2. So the interquartile range, IQR, is equals to upper quartile, which is root 3 on 2, minus the lower quartile, 1 over 2. And leave it as an exact answer, root 3 minus 1 on 2. This is the interquartile range. So how? When you said like, oh, isn't it my 1 minus A? Actually, no, it doesn't really mean anything. But the interquartile range is basically they're asking, okay, what's the range between these two values A and B? Okay, not A and 1, but between A and B. Does that make sense? Yeah. So A and B once again are the numbers on the number line. Okay, and those numbers on the number line goes to the limits on your integral. Okay. Yeah. See the connection there? Yeah. The numbers on the number line goes to the integral as limits, and then the area is the answer of the integral. Okay, so when you integrate, the answer is an area, right? But you integrate between two limits, and then the numbers on the number line are the two limits. Interquartile range, upper quartile, lower quartile, and the median, they are all numbers on the number line. They will be the limits in your integral. Okay, yeah. So I'm linking a lot of concepts here. All right, so this is the interquartile range. Yeah, they don't even give you the exact answer. That's fine. All right, we'll try one of the questions. Once again, I'll give you guys a. I'll actually try question 3 here. They already asked. They're already giving you the idea here. Okay, question 2. Find A such that PR of x less than A is 0.25. What is A? What is A? For question. What's the meaning of the value A here? This is the, anyone?
Lower.
Yes, the lower quartile. Yes, this is the lower quartile value. That's right. Okay, and then what is B then?
Okay.
Yes, this is the upper quartile because the area to the left of that is 0.75. Okay, so essentially a question A and B is just asking you to find lower and upper quartile. They already gave you the format, right? And then C is just interquartile range. Right, go, get started. Question 3. giving you guys some scaffolding there. Okay, work through it so you can get to the answer. Any question? No? Okay, just work through it.
Wait, for A, would you fancy deriving from 0 to A?
Yes, from 0 to A, yes. Alright, because area to the left of A is 0.25. Okay, so question 3, technically you can just get the exact answer, but if you get a decimal number, that's okay too. The answer are all decimal numbers. Once you are done with that, try question 6. Okay, so after you've got this one correct, move on to question 6 on the worksheet. Any question there, Sahab? Alright, we're moving on to question 6. Question 6 is a combination of every single concept in this chapter. Interquartile range, then mean, and then variance. Everything in the one question. I'll slowly work out the answer for question 6 here. So another question 6 is a calculator question, yeah? So I have to use calculator to solve it, not by hand. Okay, the answer for A is up. Equals 0, yeah? Oh, yeah, okay. Draw A value, yeah. Okay. Seems that you guys can do A comfortably, and just gotta do B. B is even easier for a calculator question.
So no solution found.
For which one?
B.
For B? Let me see. Oh, 2b minus b squared, not minus 2b squared. Yeah, it's 2x minus x squared. Yeah, 2b minus b squared. So you're just copying the answer. You have to, is when it says using GC, you gotta punch into GC. Okay? I'm not giving you guys the answer so you guys can copy. Remember, you have to use these chances to practice. So work through the question yourself. Alright? And then, because if it's a new question, it's okay to copy down the answer, but this is not a new one. We've done a few of these questions before. You have to try to do it yourself. Don't wait for my answer. If you guys are done with this, spend the last few minutes, work out question 8. It should be exactly the same. Okay, if you're done with question 6, do question 8. Okay, I'll pause the recording because I will not go through the answer of question 8. You guys gotta work through the answer yourself for question 8. I'll just check your answer and see if it's correct.